Hi there, this is Sean, and Field Application Engineer from TMYTEK. Today we are going to demonstrate about NextGen, which can be upgraded to support mmWave communications and used for educating the next generation in mmWave technology with various software interfaces and principles. So let's get started. We use NextGen to conduct a simple beamforming experience to demonstrate our hardware setup. We have an SDR to connect it to our computer for baseband signal generation. And NextGen LO provides to 2 UD boards and SDR for the missing. Then, transmission and reception are carried out through the B board and the COCO antenna. We use the LabVIEW software to configure our SDR for the transmitting and receiving signal, provide the IF signal, and we only have to adjust the outputs, the IF signal, the power, and the desired number of QAM to establish communication. The signal constellation shows a signal performance in the results. By using our GUI to control the B-board and adjusting the parameters of phase in different channels, we achieve the constructive and destructive interference as mentioned in the left sheet, ultimately achieving the beamforming control. Here, we adjust the beam steer to 30 degrees, and you can observe a significant decreases in the quality of the transmitted signal. When the signal is moved back to the 0 degree, and attempting to restore the communication, the signal quality improves once again. In this second demo, we use the NextGen to interface with the GNU Radio, the open source software interface for the radar applications. We utilize the SDR for baseband generation and control of the CW radar signal, and use the LO as the signal source for the UD board, and mixing with the SDR radar signal. Then we utilize UD boards for signal mixing and transmission through the B board, while the processing the signal receives signal with filter module along with the COCO antenna. The ultimate goal was to evaluate Doppler shift performance and display the process shift signal on this block, and converting the Doppler shift to audio output, displaying the result through the sound card on this block when there is movement of obstacles. The sound will change accordingly, making it an interesting experience that further demonstrates the feasibility of this architecture, supporting the multiple applications from beamforming to radar systems. Alright, have any questions? It's time to kick off the Q&A section.